this practice we are going to analyze the 1045 properties according to different tests. The tensile test consists in using the universal machine in order to break this piece. After you make the test, you get a graph that lets you know more information. First, you need to measure the initial area of this part and the initial length of the tooth. After the test, you need to measure the final area and the final length. With that information, you can know that the deformation of the area was equal to 33.6%, and for the length it was equal to 7.64%. Then you can calculate the modulus of elasticity that was equal to 58.5 times 10 to the 6 psi, the yield strength that was equal to 105 times 10 to the 3 psi, and the tensile strength that was equal to 112 times 10 to the 3 psi. Also, I investigated the data from the book and compared the obtained data from the book to the obtained data of the test, and we got a percentage of error of the modulus of elasticity equal to 48.88%, and for the tensile strength an error of 24.42%. Photography, I did this bakelite in order to analyze it in the microscope. You need to give it a chemical attack to the piece in order to see this image in the microscope. After that, you need to count all the number of grains and calculate with it the ASTM that in this case was equal to 10 ASTM for the 1045 steel. Impact test, we use the impact machine in order to break the metal. After you apply the force, you can know the total amount the metal absorbed. In this case, the 1045 steel absorbed a total of 40 feet-pounds. So we can know that this kind of metal is moderate ductility, is not the best one, but its behavior was good. Finally, for the hardness test, I use the Brinell, the Vickers, and the Rockwell machines. Each machine does an indentation with a load, and you need to measure the diameter of the indentation in order to get the hardness. First, for Brinell, I got a diameter average equal to 3.56, and after that I calculated the hardness with this equation, and I got the hardness equal to 290.5 HV. And the investigated one, the hardness, was 281, so the percentage of error was equal to 3.27. For the Rockwell, I got the HRZ equal to 26.4, and the investigated one was 20, so the error was 24.24. And finally, for the Vickers, the machine just give it to you the results, so I got 291.66 as an HEV average hardness, and the investigated one was equal to 281. So finally, I have a net error equal to 3.65. It is very important to choose correctly the material you want to the determinate application. If you don't choose correctly the material, you can have monetary losses or life losses that are not acceptable in the real life. So knowing the material you have in your hands is very important because you know how it's going to behave. I think also it's very important to know all the tests, the tensile, the impact, the hardness, and the metallurgy, because in this way you can now make the test to other type of material for future applications as the final project that we are also going to make similar tests in order to know how it's going to behave the material in the real life.